All right, in this example, we're told that gravity causes a falling object to accelerate at approximately 9.8 meters per second toward the Earth. And if a ball is dropped from the top of a 45-meter tall building, how long will it take to hit the ground? And how fast will it be going when it hits? All right, so don't go reaching for some physics formula. I know this sounds like a physics problem, but we're just going to use what we learned here. Now, I have to have a frame of reference. And when you're talking about falling bodies, so let's say this is the building and say this is the ground, right? So I'm going to draw this. So there's our ground. And we know that this is 45 meters tall, right? So typically we would call the ground 0, and this would be 45 meters up, right? And also our frame of reference, our frame of reference is with the ground at 0. And usually down means negative. So negative velocity is down. Okay. So because gravity is acting in the downward direction, we can say that the acceleration is a negative 9.8 meters per second squared because it's pulling down in the downward direction. All right. So we're going to just graph velocity over time again. But in this case, we're going to have some negative acceleration going on. So I'm going to draw my axes like this. You'll see why in a minute. But we're choosing a vertical frame of reference where down is negative. Okay, so my velocity is just equal to acceleration times time, but in this case, it's going to be a negative 9.8 times time. Okay, so I'm starting out here at 0 at the top of the building. All right. My velocity is 0. And then it's being this, when it's dropped from the top of the building, gravity is pulling it down at and accelerating it at 9.8 meters per second per second. Okay. So my velocity is negative, and it just becomes faster because it's accelerating. Right. And so my velocity is equal to negative 9.8 times time. All right. So, and at some point it hits the ground, right? And that's going to happen when the distance is negative 45 meters. And it's negative because it's fallen, right? It's fallen by 45 meters. Okay. So the distance from the ground has decreased, right? It started at 45 and it's decreased by 45 when it hits the ground. All right, so my distance has decreased. So my distance is a negative 45. All right, now we'd like to know, let's say this is T final. We'd like to know that time, and we'd like to know this, what is its final velocity right here? V final. So we have a triangle, and the sides of this triangle are V final, and the other side here, T, is just our T final, right? Those are the sides. All right, so distance, the distance, which is my negative 45, is equal to 1/2 V final times T final. Okay. Now we know that if we put in T final here, V final is equal to, my final velocity is equal to negative 9.8 meters per second squared times whatever the T final is. So I can make that substitution in here. 1/2 negative 9.8 T final times T final, right? So I end up with, if I take half of negative 9.8, I get negative 4.9, and then T final squared. All right. Now I know that has to be negative 45, right? Because that's how tall my building is, and I'm looking for, I know that when it hits the ground, the distance will have gone, will have fallen by negative 45, by 45 meters. All right, so now I can solve for the time. So I'm just going to divide both sides by 4.9. So T final is going to be negative 45 over negative 4.9. And then I'm going to take the square root of it. I'm only looking for the positive time. I'm not going to be looking back in time. So that's going to be my T final. And when I do that, when I put that in my calculator, I get 3.03 seconds. All right. So that tells me how long it took to hit the ground. It took 3 seconds for this object to hit the ground. And I also want to know what's the final velocity at that when it hits the ground. And now that I know it took 3.0 seconds, I can use my equation for velocity. So the final velocity then is negative 9.8 times 3.03. So I get a negative 29.7 meters per second. Okay, and it's negative because it's obviously it's falling, right? It's traveling in the downward direction. So this negative tells us the direction of the velocity. It's down, right? Which makes sense because gravity is pulling down. All right, well, that's all the examples I have for you. And you can take a look at the discussion questions and I'll meet you in class.